Yeah, I got the new pen. That's why I made a video. Talking about peat formation. Peat forms when plant material does not fully decay in acidic and anaerobic conditions. It is composed mainly of wetland vegetation, principally bog plants, including mosses, sedges, and shrubs. As it accumulates, the peat holds water. This slowly creates wetter conditions that allow the area of wetland to expand. Peatland features can include ponds, ridges, and raised bogs. The characteristics of some bog plants actively promote bog formation. For example, sphagnum mosses actively secrete tannins which preserve organic material. Sphagnum also have special water-retaining cells known as hyaline cells, which can release water, ensuring the bogland remains constantly wet, which helps promote peat production. Most modern peat bogs formed 12,000 years ago. In high latitudes, after the glaciers retreated at the end of the last ice age, peat usually accumulates slowly at the rate of about a millimeter per year. The estimated carbon content, blah blah blah, accumulates slowly at a rate about 1 millimeter per year, or it just doesn't accumulate anymore. Now to the next one. Wikipediaing shockwave. In physics, a shockwave, also spelled shockwave or shock, is a type of propagating disturbance that moves faster than the local speed of sound in the medium. Like an ordinary wave, a shockwave carries energy and can propagate through a medium, but is characterized by an abrupt, nearly discontinuous change in pressure, temperature, and density of a medium. For the purpose of comparison, in a supersonic flows, additional increased expansion may be achieved through expansion, when also known as the Prandtl-Meyer expansion fan. The accompanying expansion wave may approach and eventually collide and recombine with the shock wave, creating a process of destructive interference. Unlike solitons, another kind of nonlinear wave, the energy and speed of a shock wave alone dissipates relatively quickly with distance. When a shock wave passes through matter, energy is preserved, but entropy increases. This change in the matter's properties manifests itself as a decrease in the energy, which can be extracted as work and as drag force on supersonic objects. Shock waves are strongly irreversible processes. Yeah, I warned you. I am not as good as a painter or drawer as Alan Watts or Graham Hancock. And this is not after school. But anyway, let me explain. Let's start from the bottom. This is, first of all, really, really, really simplified. Okay. Here, it's hot. Let's call it magma. And here we have the groundwater layer. There might be something in between too. I said it's really, really simplified. And then we have the crust or bedrock, or how you put it. And on top of that, we have the sediments, gravel, or whatever you have there then. Or maybe there wasn't anything there before the event. Everything maybe just got brought there, like the whole mountain just blew there by wind, which I try to represent in those wavy forms. So now, we have a lightning. Hopefully you recognize that, which is hitting the ground. There is stuff going on, and I'm not talking about lightning bolts we see today. I talk about much bigger lightning strikes and much longer in duration. Nowadays, a lightning strike, few milliseconds, and it's over. So now we imagine lightning strikes which last for half a minute or something. Scalability. So now we have this lightning strike hitting the ground, and there's stuff is. It depends on the strength of it and the duration and of the ground composition and all kinds of things, but it can penetrate really deeply into the ground. If it's coming 20 kilometers from above, it might be penetrating 20 kilometers into the ground as well. And as we all know, that lightning strikes are always both direction events. So now we have a forest here, deers, rabbits, especially white rabbits. And they didn't knew what's going on. Then the lightning strike hit. And this is the shock wave, which is going to that direction. And somehow I understood that this shock wave by itself has more energy than the surrounding. Let's put pluses here, which is saying much energy. So the shock wave, first of all those trees, they get blasted into really small pieces really quickly. Some of them burn up in the sky through the heat, which is from the lightning strike, and other pieces of the debris which is flying around, biomass, let's call it, rabbits and what have you, Neanderthal people. Only the hardest, like if you take a tree, like everywhere where you have a branch, it's much harder, the wood, so it's much more dense. And these kind of things, they don't burn up totally. But since they have their own electrical properties and charge and all this kind of stuff, maybe they get amped up in a way through the shock wave, which is in a way neutral. It just like condenses the overall electric field as it propagates through space. And the stuff somehow gets stuck to that wave here. And as we just read before, the shock wave is dissipating really quickly when it's traveling somewhere. So now imagine this is now the peak of the shock wave and it will dissipate really quickly. And all the peat, and now let's say all the stuff, the biomass, which got now altered electrically, it's now dielectric and heavier than water and these kind of things because it got silicified. It's like petrified wood in really, really, really small pieces. It's really fine dust, but it's heavy. And we have the wind, like overall wind conditions, which just maybe there it's windy when the lightning strike hits, and then we have the shock wave, and then we have the usual wind, and these kind of things. And it might accumulate onto the ground. Like here, I try to draw these kind of things. When it's raining, it get washed inside, and other stuff is just like laying on the floor around. And maybe even the lightning strike itself will create this kind of indentation in which where we found then later peat, which got washed down from the hill by rain. This is a raindrop. Okay. 12,000 years ago, we had this kind of things going down here on Earth. We have no one to talk, to ask about these things. But if you go to Google Earth, yeah, still stuck in the North Pole. Here we have peatland. You can see it from space. It's red. And obviously, it is really a craterish environment with all sorts of really interesting features. Yeah, this seems to be man-made in a way. Yeah, we are somewhere in Russia. And here it's also nice to see we have a crater here in the middle, which might have this kind of electrical property to itself. And the peat, since it's dielectric, it forms daisy chains, which is also an electrical phenomena. But I am no electrical engineer, nor a drawer, painter. So don't expect me to paint too much. I just tried a new pen. And since I haven't still yet found any explanation for the creation of peat, like an explanation which would be for me that I can say yes, I can agree. I can wrap my head around this theory or whatever it is. It's somehow a mystery. No one knows how peat got created. It's just there. And we just use it. We know the properties of it. We know how to use it. We know it's like really dusty and we know it's dielectric and, acid. And it doesn't do much. It doesn't grow really. 1 millimeter a year. Maybe they just had to say something. It doesn't grow at all. Like there's just leaves falling on top of it. That's the millimeter what you get. But the actual peat mass maybe doesn't grow at all. Because we are missing the electrical input in order to form it again. Like shock waves, which is somehow, how to put it, a neutral electrical event. The shock wave itself, it just ionizes all the things which comes into its path. And we have heat which burns things up and all the stuff which didn't get burned up while flying through the air. Maybe it flew a few hundred kilometers through the air. Who knows? I don't know. It got picked up by the wind and or maybe not. I don't know. So that's my theory about peat. And maybe I got to write something about that. But I leave it here. If you have an idea or know how peat got created in the first place, like if you have this kind of source, I spent many hours Googling about peat, how it got formed, no one knows. They just don't. How is it possible? But I leave it here. If you know something I don't about peat or a source or whatever, if you know how to say about electricity and shock waves and these kind of things, which could be related to peat and where you find peat on Earth and all these kind of things, leave a comment. It would be interesting. Thanks. Bye.